one shear stress. Fine. So today we are going to start the derivation to calculate the what to say transform normal stresses. ठीक है जी, transform normal stresses and transform shear stresses. So if we look into the book, we are following R.C. Hibbeler 8th edition, chapter number 9. So last time we have done this. So today we want to start the derivation. So if you see these equations, okay, this sign convention we have also studied last time. So this is your general what to say plane state of the stress. You can see your element is oriented along the normal x and y axis, and you have this normal stress sigma x, you have this normal stress sigma y, and you have this shear stress tau x y. Fine. So this is your plane stress state. ठीक है जी, sigma x, sigma y, and tau x y. Then this is now the condition which we want to study. Now you can see that your axis, x dash axis, is oriented at an angle theta with respect to x axis. Your x dash axis is oriented at an angle theta with respect to x axis. ठीक है जी? Now I want to calculate normal stress about x dash axis. I want to calculate normal stress about y dash axis. I want to calculate the transformed shear stress about y dash axis. ठीक है जी? The plane stress state is which is shown over here is given to me, that is along regular x and y axis. Now I need to calculate the transformed normal stresses about x dash and y dash axis. Your x dash axis is oriented at an angle theta with respect to x axis, and you can see this theta is shown as positive because this is counterclockwise. So we can also prove it that counterclockwise is positive, that if we curl the fingers of the right hand in the direction moving from x to x dash axis, then our thumb will point out of the plane that represents the positive z-axis. So counterclockwise orientation is considered positive. So now I want to calculate the normal stresses and shear stresses about these transformed x dash and y dash axis. Our objective is that to calculate transform normal stresses about x dash and y dash axis using this plane stress state sigma x, sigma y, tau xy, and relating the or developing a relationship between plane stress state and this orientation theta. ठीक है जी? So these are the equations which we have to derive today. This equation is sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sin 2 theta. Now, if you see this, sigma x dash is your transformed normal stress about x dash axis, and it is a function of normal stress sigma x, sigma y, tau xy, which are your plane stress state stresses, and we are adding this theta. ठीक है जी? We are adding up this theta so that if we want to find the normal stresses at any orientation, we just put the value of theta and we can get the value of our transformed normal stress. Then we have this transformed shear stress tau x dash y dash that is equal to minus sigma x minus sigma y over 2 sin 2 theta plus tau xy cos 2 theta. Now again in the transformed shear stress, you can see you have sigma x, sigma y, and tau xy. The norm plane stress state. Okay? Then you have this. Now you have introduced the value of the theta. So with changing orientation, you can calculate the changing value of the transformed shear stresses. The third equation which we need to derive today is the transformed normal stress about y dash axis. Transformed normal stress about y dash axis. So you can see this sigma y dash is equal to sigma x plus sigma y over 2 minus sigma x minus sigma y over 2 cos 2 theta minus tau xy sine 2 theta. The difference between sigma x dash equation and sigma y dash equation. The difference between the two equations is only of the signs. Over here it is positive, positive. Over here it is negative, negative. So normal stress equations, transform normal stress equations, sigma x dash and sigma y dash, they are similar. Only difference is that in sigma x dash you have positive signs, whereas in sigma y dash you have negative signs. And how this derivation will proceed. So this is your plane stress state element. This is your plane stress state element. About x-axis, regular x-axis, you have sigma x. About y-axis, you have sigma y. And you have this shear stress, tau x, y. You have this shear stress, tau x, y. Fine. Now, there is one thing. These are the transformed axis, x dash axis and y dash axis. So now we want to derive the equation. So we have this y dash axis and we have this x dash axis. So to derive these equations, first we will cut the section along the y dash axis, and then we will later on cut the section about x dash axis to develop these equations. So in the first step, they have cut the section along y dash axis, or you can say the section has been taken along the plane y dash, and you got this segment. Now remember one thing we have studied earlier, that this plane, the plane about which you will cut the section, it will have an impact on the resultant normal and the shear stress. So which means that if I cut the section about y dash axis, I will get different value of the normal and the shear stress, transform normal and shear stresses, then when I will cut the section along x dash axis, along the x dash axis. Okay? So now you can see this. This is the section which has been cut along y dash axis, and we got this diagram. Now first they are showing you that along this section, area of this is delta A. So arbitrarily the area of this part has been taken as delta A. Now this is your theta. This angle is 90 degrees. So this is over base and this is over perpendicular. So the component of this area delta A along the base is delta A cos theta, and along the perpendicular it is delta A sin theta. Okay, is this point clear?
Yes, sir.
Okay, now you can see this on this element, there was this sigma x, sigma y, and tau xy. Now over here on this figure, complementary normal stress sigma x has been shown, complementary shear stress tau xy is shown, and complementary normal stress sigma y is shown. So when we cut the section about y dash axis, we get this section. Now first we have what you say, resolve the area delta A into its components about vertical x and vertical y and x axis. So This is delta A cos theta. This is delta A sin theta. Now we come to this figure. So now if you see, this is your transformed y dash axis. This is your transformed x dash axis. Transformed x dash axis, transformed y dash axis. Now, if you see, these are the normal and the shear stresses which are acting on this part. So you have sigma x, ठीक है जी? You have sigma x, you have tau xy. This is tau xy, and this you have sigma y. Now these stresses have been converted into forces. So stress is equal to force per unit area. So force is equal to stress into area. So force is equal to stress into area. So this stress is sigma x delta A cos theta. So we have multiplied the stress sigma x with area, that is delta A cos theta, sigma x delta A cos theta, to get the normal force. Then we have this tau xy, we have multiplied it with delta A cos theta. The area component along this base is delta A cos theta. So that's why you are seeing delta A cos theta be multiplied with sigma x and tau xy. So now we have converted these stresses into forces. Then you have this sigma y and tau xy. So over here, to convert this normal and shear stresses into normal forces and shear forces, we will multiply this normal stress sigma y with the area delta A sin theta. The area component along the perpendicular is delta A sin theta. So we will multiply sigma y with delta A sin theta to get the normal force sigma y delta A sin theta. Then we have the shear stress tau xy. We multiply it with delta A sin theta to get the shear force. Then the resultant normal stress is sigma x dash, which is acting along x dash axis, sigma x dash, which is acting along x dash axis, and we have multiplied it with delta A to convert the normal stress into normal force. Then along the y dash axis, you have tau x dash y dash. Along the y dash axis, you have tau x dash y dash. So you multiply it with the area, because area along the face is delta A. So you will get the resultant shear force. Fine. So this is one figure, in which you have this resultant normal force sigma x dash delta A, resultant tau x dash y dash delta A, and you have these normal and shear stress forces. These two forces, they are oriented about x dash and y dash axis, whereas these two and these four forces, they are oriented along x and y axis. So we need to resolve these forces into their components about x dash and y dash axis. So then we can apply the equations of equilibrium by applying that the summation of forces about x dash axis is 0 and summation of forces about y dash axis is 0. So applying that summation of forces about x dash axis 0 and summation of forces y dash axis 0. So we will get these equations. In the second half, what we will do, we will cut the section about x dash axis, and in that case again we will apply these normal and shear stress forces acting about x and y axis. We will apply the resultant normal and shear stress, and then we will resolve these forces into their components. Then we will resolve these forces into their components. And then again we will apply summation of forces about x dash axis 0 and summation of forces about y dash axis 0 to get these to get this expression sigma y dash. Fine. So this is just a general overview what we are going to do. So in the book you can see they have drawn these figures and then they have resolved these forces into their components, and then they have what you say applied the equations of equilibrium, that summation of forces about x dash axis will be 0 and summation of forces about y dash axis will be 0. This is just the overview. Now we will do these derivations step by step. Is this point clear? If you have any query, please ask me now. No query? No query?
No, sir.
सर एक्सक्यूज मी
जी बोले सर,
सर
प्लीज बिट लाउडर बिलाल मिर्जा।
जी सर, ये अगर हमने बीम एलिमेंट लिया है तो सर इसमें जी एक्सिस नहीं आएगा?
किसमें?
सर ये जो एलिमेंट लिया जिसमें सेक्शन कट किया, जिसपे स्ट्रेसेस और शेयर फोर्स अप्लाई हो रही है,
नहीं
सर उसकी क्या रीजन है?
उसकी रीजन ये है कि वी आर वर्किंग इन बाईएक्सियल स्ट्रेस स्टेट इन व्हिच वी जस्ट हैव एक्स एंड वाई एक्सिस। ठीक है, आपका एक्स और वाई एक्सिस है, जस्ट यू हैव रोटेटेड इट by an angle theta. So you are just working in x and y axis, you are not working in z axis. So if you recall in your biaxial stress state which we have studied last week, in that we have assumed that there is no normal stress acting along the z-axis. Then we come to the conclusion that in biaxial stress state there are what you say two normal stresses and one shear stress. So now we are going to work on that what you say biaxial stress state, which is your plane stress state.
Okay sir, thank you.
So now let's start the derivation. So I would like all of you to do the derivation with me, and at the end of the lecture I will randomly ask the students to switch on their cameras and show me the derivation. So everyone please open up your what you say registers and pens. So let's start with our derivation. Bilal, first let me answer your question again by the figure
Yes.
now. This is x-axis, this is y-axis. Fine, regular x and y-axis. Now your axes are now rotated by an angle theta. So your now transformed axis or rotated axis are x dash and y dash axis, which are oriented at an angle theta. Keep one thing in mind, that the angle between x-axis and y-axis and x dash and y dash axis, that will remain 90 degrees. So only the axes are rotated, but we are still working in biaxial stress state, plane what you say plane stress state. Okay, we are not working in general stress state or triaxial stress state. We are working on biaxial stress state. Okay, so just over axes are rotated. X is rotated by an angle theta, and this is now your x dash axis. So y is rotated, and this is your y dash axis. Fine. So now, guys, let's start the derivation. Just a moment, I have to add one student now. Just a moment, please. 2017. One. One moment, guys. I just have to add one student. Let's start with over derivation. Everyone can see these figures.
Yes, sir.
Yes, sir.
Okay. So first we are going to draw this figure. ठीक है जी. So this red color is over element, and this is normal stress sigma x. This is normal stress sigma y. This is your tau xy. All these normal and shear stresses are positive. This is normal stress sigma x in the positive x direction. This sigma y normal stress in y direction for pointing or is in the positive y direction. Then this shear stress tau xy, this vertical component of the shear stress is directed upwards, so it is positive. So this is your direction which we have taken. This is x-axis, this is y-axis. And this is sigma x, this is complementary sigma x normal stress. This is sigma y, this is complementary normal stress sigma y. This is shear stress tau x y. This is complementary shear stress tau x y. This is your y dash axis. So now this is y dash axis and x dash axis. So this is my y dash axis. I have cut the section about this y dash axis. So once I have cut the section about y dash axis, this is now the section which we have. This is y dash axis, this is x dash axis. Area of this section is taken as delta A. Delta A. This is angle theta, the rotation of the y-axis with respect to y dash axis, or you can say x-axis to x dash axis. Then we have resolved this delta area, delta A into its components about vertical, about this base and the perpendicular. So about the base, the component will become delta A cos theta, and about the perpendicular, this area component will be delta A sin theta. Guys, please draw these two figures. This is your figure 1 or figure A. This is figure B. Please draw them and let me know if you have any issue. Guys, have you drawn the figure? This one. So shear stress tau xy. Then we have normal stress sigma y. This one green color. Then we have this sigma y. And we have this shear stress tau xy. These are stresses. These are stresses. Now we know that stress is equal to force per unit area. Stress is equal to force per unit area. So force is stress into area. So we are going to multiply the stresses with their respective areas. Along this phase, the component of area is delta A cos theta. So this stress will become sigma x delta A cos theta. This stress tau xy will become tau xy delta A cos theta. The area component along this phase is delta A sin theta. So I will multiply sigma y with delta A sin theta, tau xy with delta A sin theta to get the force component. Sigma y delta A sin theta, tau xy delta A sin theta. Is this clear?
Yes, sir.
Yes, sir.
So now we have sigma x delta a cos theta, tau xy delta a cos theta, tau xy delta a sin theta, sigma y delta a sin theta. These four forces are oriented along x and y axis. ठीक है जी? So I am required to resolve these forces into their components about x dash axis and y dash axis. ठीक है जी? So this I will do now. So please draw this figure so that we can proceed further. So this is your figure number 3 or figure C.
Yes, sir.
Okay. Let me share the next figure. Can you see this figure now?
Yes, sir.
Yes.
Now, these were the four forces which are oriented along x and y axis. This is your resultant forces, sigma x dash, tau x dash, y dash. We have multiplied it with the area, that is delta A to get the force component, the resultant force, sigma x dash delta A about x dash axis, tau x dash y dash delta A. ठीक है जी? So now you have four forces, ठीक है जी, which are oriented about x and y axis, and there are two resultant forces which are oriented along x dash and y dash axis. So now let's resolve these forces into their components. So first of all, draw x and y axis, regular x and regular y axis. Just draw regular x and regular y axis. So please first draw regular x and regular y axis. Okay, now draw transform x dash axis and transform y dash axis. Transform x dash axis and transform y dash axis. ठीक है जी? If you have drawn this, then let's start the force resolution. So first force is sigma x dash delta A. So I have shown this sigma x dash delta A along the x dash axis. I have shown this tau x dash y dash delta A along the y dash axis. Tau x dash y dash delta A along the y dash axis. ठीक है जी? Now let's start the force resolution one by one. So first I take this tau xy delta A sin theta, this one. So this is tau xy delta A sin theta. So this force will have two components, one along the y dash axis and other along the x dash axis. So its component along this y dash axis will be tau xy delta A sin theta into sin theta, and its component along the x dash axis will be tau xy delta A sin theta into cos theta, because this is your base, this is your perpendicular. ठीक है जी? So please make sure that you are also getting the same signs. You are getting the same signs? You guys are getting the same signs, because signs are important, because when we will do the summation of forces, equilibrium equations about x and y axis, we need to make sure that over forces are oriented in the true direction. Otherwise, what will happen? We will get the wrong signs. Okay, so if this is clear, then next, uh, if this is clear, then next is sigma y delta a sine theta. Sigma y delta a sin theta. ठीक है जी, this component sigma y delta a sin theta. So sigma y delta a sin theta will have two components, one along the y dash axis, other along the x dash axis. So this component which is along the y dash axis, this will be now sigma y delta a sin theta into cos theta, because this is your base and this is your perpendicular. So this component will be sigma y delta a sin theta into sin theta. Is this clear? Is this clear?
Yes, sir.
Okay, now next we can resolve this force sigma x delta a cos theta. So this is the force sigma x delta a cos theta. So it will have two components, one along the x dash axis, other along the y dash axis. So this component will be sigma x delta a cos theta into क्या होगा ये sigma x delta a cos theta into cos theta,
Cos
because
theta.
this is your base. ठीक है जी, and this is your perpendicular, so this will be sigma x delta a cos theta into sin theta. Fine. Now the next force which we need to resolve, that is tau xy delta a cos theta. So this is my tau xy. Uh, tau xy delta a cos theta. So we resolve this force tau xy delta a cos theta into its components about x dash and y dash axis. So it will have these two components along the y dash and along the x dash axis. So along the y dash we have tau xy delta a cos theta into cos theta, and this will be along the x dash axis, the component will be tau xy delta a cos theta into sin theta. ठीक है जी? Guys, please draw this figure, take your time, understand each and every direction. ठीक है जी? If you have a query about any force resolution, ask me now, because this is important, because if this figure is correct, then you can simply apply the equilibrium equation to obtain this summation of forces about x dash axis, summation of forces about y dash axis. जी, is this figure clear? Should we proceed further?
Yes, sir.
Okay. This was figure 2. Now let's start with figure 3. So this is going to be my figure 3. Okay. Now we will continue. We have to apply equilibrium equation. First, summation of forces about x dash axis is equal to 0. And then in the second case, we will apply the summation of forces about y dash axis 0. So let's start. So summation, first we are just going to write the force, would you say, forces about x dash axis. So we have sigma x dash delta A. Now this force sigma x dash delta A is pointing towards positive x dash axis. ठीक है जी, positive x dash direction. So this will be positive sigma x dash delta A. Sigma x dash delta A. Fine. Then next is this tau xy delta a sin theta and its component along this. ठीक है जी, this component is, this is your base, so this component is tau xy delta a sin theta into cos theta, and this arrow is pointing towards negative x dash axis, so this will be minus tau xy delta a sin theta into cos theta. Now, next one is this one, sigma y delta a sin theta. So its component along x dash axis is this one. ठीक है जी? And this component was sigma y delta a sin theta into sin theta, because this is perpendicular. And this arrow is pointing towards negative x dash axis. So this will be minus sigma y delta a sin theta into sin theta. Then you have sigma x delta a cos theta. So its component about x dash axis will be this one. So this component will be sigma x delta a cos theta into cos theta, and this arrow is again pointing towards negative x dash axis. ठीक है जी? So this will be minus. So minus sigma x delta a cos theta into cos theta. And the last one we have tau xy delta a cos theta, and along the x dash axis we have this component. This component is tau xy delta a cos theta into sin theta, and again this component is pointing towards negative x dash axis. So this will be minus tau xy delta a cos theta into sin theta. And sum of all these forces about x dash axis should be 0. If you have any ambiguity, please ask me now. If you have any ambiguity, please ask me now.
सर इसमें हेड टू टेल रूल्स के अकॉर्डिंग जो साइंस हमने दिए हैं, जो इंक्लाइन में सिग्मा एक्स डैश एक्सिस में वाला है
जी,
और सर जो एक्चुअल में है वो पॉजिटिव साइंस के साथ ले रहे हैं, लेकिन जो हेड टू टेल रूल्स के साथ डायरेक्शन दी है वो तो नेगेटिव बन रही है.
नहीं, you can simply keep it in this way, that the vector AB plus BC is equal to AC. It's not possible. I have already solved this multiple times. Next, we have summation of forces about y dash axis is equal to 0. Summation of forces about y dash axis is equal to 0. So we have this, first of all, this component which is acting along y dash axis, that is tau x dash y dash delta a. Tau x dash y dash delta a acting along y dash axis, and it is acting towards pointing towards positive y dash axis, so it is positive. Tau x dash y dash delta a. Now next we have is tau xy delta a sin theta. So its component about y dash axis is this one. So this is tau xy delta a sin theta. This is perpendicular, so this will be sin theta. Tau xy delta a sin theta into sine theta, and this arrow is pointing towards positive y dash direction. So this will be positive. So positive tau xy delta a sine theta into sine theta. Then we have sigma y delta a sine theta. Its component about y dash axis is this one. So this component is sigma y delta a sine theta into cos theta, and it is pointing towards negative y dash axis, means it's pointing towards downwards. So this will be minus sigma y delta a sine theta into cos theta. Then we have sigma x delta a cos theta. Its component about y dash axis will be this one. So this is perpendicular, so this will be sigma x delta a cos theta into sine theta, and this is pointing towards positive y dash direction. It is pointing towards positive y dash direction. So this is sigma x delta a cos theta sine theta. Then next one is tau xy delta a cos theta. So it has this component tau xy delta a cos theta has its component about y dash axis, this one. So this is the base, so it will be tau xy delta a cos theta into cos theta, and it is pointing downwards. It is pointing downwards, so it will be negative, minus tau xy delta a cos theta into cos theta. Everyone got this summation of forces about x dash axis and summation of forces about y dash axis equals to 0.
Yes, sir.
Should we proceed further? Should we proceed
Yes,
further?
sir. Yes, sir.
Yes, sir.
So now we should be figure number is 4. ठीक है जी. Now what we are going to do, we have already have the expressions that summation of forces about x dash axis 0 and summation of forces about y dash axis 0. So now what we have done here, this is the same equation which we had developed earlier. What we are doing, we are taking delta a common. We are taking delta a common from all the coefficients and equating it equal to 0. So delta A will become 0. So over equation will become sigma x dash minus tau xy sine theta cos theta minus sigma y sine square theta minus sigma x cos square theta minus tau xy sine theta and cos theta. So now simplifying this equation, we have sigma x dash minus sigma x cos square theta minus sigma y sine square theta. Then you have minus tau xy sine theta cos theta minus tau xy sine theta cos theta. So this will become minus 2 times tau xy sine theta cos theta, and that is equal to 0. Now we are going to take these coefficients on the other side of the equation. So the equation will become sigma x dash is equal to sigma x cos square theta positive plus sigma y sine square theta plus 2 times tau xy sine theta cos theta. Please do this, and if you find any difficulty, please let me know. Everyone is getting this expression. Everyone is getting this expression. Everyone is getting this expression.
Yes, sir.
Okay, now summation of forces about y dash axis is 0. That is the equation in which the one which we have formulated earlier. Just what we have done is we have again taken delta A as common. So then we have equated delta A equal to 0. So delta A is eliminated from the equation. So this equation now becomes tau x dash y dash plus tau xy sine squared theta minus sigma y sine theta cos theta minus tau xy cos squared theta plus sigma x cos theta sine theta. ठीक है जी, plus sigma x cos theta sine theta, ठीक है जी, is equal to 0. So the same equation which we have formulated earlier, we have just taken delta A as common and we have equated delta A equals to 0 and we have eliminated delta A from the equation. Now what we will do, we will have tau x dash y dash. So these coefficients, these four coefficients I am going to take on the other side of the equation. Then that will become first minus sigma x cos theta sine theta. Then you have this one plus. Now on the other side it will go, so this minus will turn to plus sigma y sine theta cos theta. And then you have this plus tau xy sine squared theta. On the other side it will go and become minus tau xy sine squared theta. This minus tau xy cos squared theta. On the other side it will go, it will become plus tau xy cos squared theta. Okay? Now what we are going to do, tau x dash y dash, we are taking this sine theta cos theta as common, so this will become minus sigma x plus sigma y sine theta cos theta. Then we are taking tau xy as common here, so plus tau xy cos squared theta minus sine squared theta. ठीक है जी, so over tau x dash y dash equation has become minus sigma x plus sigma y times sine theta cos theta plus tau xy cos squared theta minus sine squared theta. Everyone is clear with these two equations?
Yes, sir.
Let me share the next figure. Next figure is this one. Figure number is 5. So all the working which we have done so far, that was by cutting the section or by taking the plane y dash axis. Now we have got the expressions for sigma x dash and tau x dash y dash in terms of plane stress state sigma x, sigma y, tau xy and theta. Okay, now we want to derive the equation for what to say, this sigma y dash. Now from the procedure which I am going to explain now, this will be used to get the expression for sigma y dash, and this procedure can also give you tau x dash y dash. So your expression for tau x dash y dash, ठीक है जी, your expression for tau x dash y dash, it should be same by both the methods, by both what you say sections. Okay, expression will be same. Okay, now let's start from here. So you have plane stress state element. You are shown normal stress sigma x, normal stress sigma y, shear stress tau x y. These are the what you say complementary normal stress sigma y. This should be complementary normal stress sigma x. This is your complementary shear stress tau x y. So now we have cut the section. So this is your x dash axis and this is your y dash axis. So now I have to cut the section about x dash axis. So I have to cut the section about x dash axis. Okay? So now I will cut the section about x dash axis. So I will get this figure. So this is my figure number 2. This is your face. Okay? This is your face delta A. ठीक है जी, this is your x dash axis, y dash axis. So the component area component about x and y axis will be delta A sin theta and delta A cos theta, because this is your base and this is your perpendicular. So this is delta A cos theta, this is delta A sin theta. Is this figure clear? Can you please draw these two figures, figure 1 and figure 2? Please draw this figure. Have you drawn this figure 1 and figure 2? If you are done with this, then we are moving to figure 3. So this is the section which we have cut. This is your x dash axis, this is your y dash axis. Along the x dash axis, you have tau x dash y dash delta A. Along the y dash axis, you have sigma y dash delta A. Then you have these normal and shear stresses, sigma x, tau xy, sigma y, sigma y, ठीक है जी, and tau xy. Is this clear? Tau xy, sigma x, sigma y, tau xy. Is this clear? Is this clear, guys? Can you hear me?
Yes, sir.
Yes, sir.
Okay. So along this face, which is basically your base, along this face, area component is delta A cos theta, delta A cos theta. Along this face, which is your perpendicular, area component is delta A sin theta, delta A sin theta. So this shear stress tau xy will become now tau xy delta A cos theta. So we have converted the shear stress into the force. Then we have this sigma y delta A cos sigma y. We will multiply it with delta A cos theta. So this normal stress is converted to normal force. Then we have then you have this sigma x delta A sin theta, tau xy delta A sin theta. ठीक है जी? So we have converted the normal stress and the shear stress, normal and the shear stress into their normal and shear forces. Sigma x delta A sin theta, tau xy delta A sin theta. ठीक है जी? So these are now 4 forces which are oriented along x and y axis. I need to resolve these 4 forces into their components about x dash and y dash axis. ठीक है जी? We have to resolve these forces into their components along x dash and y dash axis. These two forces tau x dash y dash delta A about x dash axis and sigma y dash delta A about y dash axis, these are already oriented along x dash and y dash axis. So we do not need to resolve these two forces into their components. So let's start the force resolution. So first I am going to resolve sigma x delta A sine theta into components. So first, preferably you can draw this figure. You have regular x and regular y axis. You have regular x and regular y axis. Then you have transform x dash and y dash axis, just like this one. Okay, so first we are going to resolve sigma x delta A sine theta, sigma x delta A sine theta into its components along the y dash axis and x dash axis. So this force sigma x delta A sine theta, its component along the x dash axis will be sigma x delta A sine theta into cos theta, and its component along the y dash axis will be sigma x delta A sine theta into sine theta. ठीक है जी. Then you have this tau xy delta A sin theta. Tau xy delta A sin theta. ठीक है जी. This one. Tau xy delta A sin theta. This force. Tau xy delta A sin. So its components along the y dash axis and x dash axis are these. Along the y dash axis, you have tau xy delta A sin theta into sin theta. Into cos theta. Sorry. This one is tau xy delta A sin theta into cos theta, and this component along the x dash axis is tau xy delta A sin theta into sin theta. Then you have this sigma y delta A cos theta. So sigma y delta A cos theta, it has components about y dash axis and x dash axis. About y dash axis, its component will be sigma y sigma y delta A cos theta and into cos theta, and this one will be sigma y delta A cos theta into sin theta. ठीक है जी. Then the last one is we have tau xy delta A cos theta. So tau xy delta A cos theta, its component about x dash axis will be tau xy delta A cos theta into cos theta, and along the y dash axis, its component will be tau xy delta A cos theta into sin theta. Guys, is this figure clear?
Yes, sir.
Okay, we are now proceeding further. We are now going to apply the equilibrium equations to resolve the forces into their components about x dash and y dash axis. ठीक है जी. In addition, what I have done in this figure, I have now marked tau x dash y dash delta A about x dash axis, tau sigma y delta A along the y dash axis. So now let's resolve the forces about components we have done. So now let's do this summation of forces about y dash axis 0. Why we are doing this? Because first we need to have an expression for sigma y dash. Okay, so you have, should we start now this summation of forces about y dash axis is equal to 0?
Yes, sir. We can start.
Okay, I am starting off. Sigma y dash delta A, so it is positive as it is directed towards positive y dash axis. Then you have this tau xy delta A sine theta. Its component about y dash axis is this one, which is tau xy delta A sine theta cos theta, and it is directed towards positive y dash axis. So this will be positive. Then you have sigma x delta A sine theta. Its component about y dash axis will be this one. So this component will be sigma x delta a sine theta into this perpendicular, which is sine theta. Now this force component is pointing towards negative y dash axis. So this is negative. So negative sigma x delta a sine theta into sine theta. Fine. Now, next is sigma y delta a cos theta. So its component about y dash axis will be this one, sigma y delta a cos theta into cos theta, and it is pointing towards y dash axis downwards. So this is negative, minus sigma y delta a cos theta into cos theta. Last one I have is this tau xy delta a cos theta, and it is the component about y dash axis will be tau xy delta a cos theta into sine theta, and it is pointing towards positive y dash axis. So this will be positive tau xy delta a cos theta sine theta. So everyone is okay with this equation, and that should be equal to 0. That should be equal to 0. Now we will take delta A as common, and then we will equate it equal to 0. So delta A will be removed from the equation. So now our simplified equation will be sigma y dash plus tau xy sine theta cos theta plus they are now gathering this one, plus tau xy sine theta cos theta, then minus sigma x sine theta sine square theta minus sigma y cos square theta equals to 0, Now I will move these four coefficients on the other side of the 0, and your equation will become sigma y dash is equal to sigma x sine square theta, ठीक है जी, plus this will go and become plus sigma y cos square theta, this will go and become minus on the other side, minus 2 times tau xy sine theta cos theta. So everyone is clear with this equation. Sigma y dash is equal to sigma x sine square theta plus sigma y cos square theta minus 2 times tau xy sine theta cos theta. Everyone is clear with this?
Yes, sir.
Yes, sir.
Okay, then comes the summation of forces about x dash axis is equal to 0. So let's start with, first we have this tau x. Now guys, before we start, one thing I want to let you know, this is now repeat. We already have the expression for tau x dash y dash. I just want to let you know that you can also get the expression for tau x dash y dash from this figure by cutting this section along x dash axis as well. So taking summation of forces about x dash axis equal to 0. So we have this tau x dash y dash delta A. Okay, the pointing towards positive x dash axis, which is positive tau x dash y dash delta A. Then I have this sigma x delta A sine theta. Its component about x dash axis will be sigma x delta A sine theta into cos theta, and it is pointing towards x dash axis, so it is positive. So positive sigma x delta A sine theta into cos theta. ठीक है जी, then you have this sigma y delta a cos theta, so its component about x dash axis is this one, which is sigma y delta a cos theta into sine theta, and this component is pointing towards negative x axis, so this will be negative, minus sigma y delta a cos theta times the sine theta. Next, I have tau xy delta a cos theta. So its component about x dash axis will be this one, which is tau xy delta a cos theta into cos theta, and it is pointing towards negative x axis. So it will be minus tau xy delta a cos theta cos theta. Then I have this component tau xy delta a sine theta. So its component about x dash axis is this one. This will be tau xy delta a sine theta into sine theta, and this component is pointing towards positive x dash axis. So this will be positive. So positive tau xy delta a sine theta. Now this should be equal to 0, and then we will take delta A as common. Okay, we will take delta A as common in this equation and equate it equal to 0. So delta A will be removed from the equation. So our equation will become tau x dash y dash plus sigma x sine theta cos theta minus sigma y cos theta sine theta minus tau xy cos square theta plus tau xy sine square theta. So your equation is now tau x dash y dash plus sigma x sine theta cos theta minus sigma y sine theta cos theta minus tau xy cos square theta plus tau xy sine square theta, and we equate it equal to 0. So then I will move these four coefficients on the other side of the 0. So my equation will become tau x dash y dash is equal to, I'm taking sine theta cos theta as common. So minus sigma x plus sigma y sine theta cos theta. Then I'm taking tau xy as common. So this will become tau xy cos square theta minus sine square theta. Is this clear? So you have got the same expression for tau x dash y dash. Okay, we have got this same expression for tau x dash y dash as we have got it earlier. So is this point clear?
Yes, sir.
Let's move to the last slide, last figure. Okay, Ji, now what we are going to do, these three expressions which are written in the blank. Sigma x dash is equal to sigma x cos square theta plus sigma y sine square theta plus 2 tau xy sine theta cos theta. And sigma y dash is equal to sigma x sine square theta plus sigma y cos square theta minus 2 times tau xy sine theta cos theta. And then this tau x dash y dash is equal to minus sigma x plus sigma y sine theta cos theta plus tau xy cos square theta minus sine square theta. So these three expressions we have derived. Now we want to further simplify these expressions to get our final expression. So now what we are going to do, we are going to place the identities. What we are going to do, we are going to place the identities in the equation. So cos, there are few identities. One is cos square theta. Cos square theta is 1 plus cos 2 theta over 2. The other identity is sine square theta, which is 1 minus cos 2 theta over 2. The third identity is 2 times sine theta cos theta is sine 2 theta. The fourth identity is this one. Cos square theta minus sine square theta is equal to cos 2 theta. So these are the four identities which we are going to use to simplify these equations. So my sigma x dash equation is sigma x dash is equal to sigma x, and in place of cos square theta I have put 1 plus cos 2 theta over 2 plus sigma y sine square theta. In place of sine square theta I have put 1 minus cos 2 theta over 2 plus tau xy 2 sine theta cos theta I have replaced with the identity sine 2 theta. Okay, now I will simplify this equation first by opening the bracket. So this will become sigma x dash is equal to sigma x dash over 2. You get the sigma x times 1, so sigma x over 2 plus sigma x cos 2 theta over 2, sigma x cos 2 theta over 2 plus sigma y into 1 over 2 minus sigma y cos 2 theta over 2, sigma y cos 2 theta over 2 plus tau xy sin 2 theta. Now I'm just going to rearrange the coefficients. So sigma x dash is equal to sigma x over 2 plus sigma y over 2. So this will become sigma x plus sigma y over 2 plus sigma x over 2 cos 2 theta minus sigma y over 2 cos 2 theta. So this will become sigma x minus sigma y over 2 cos 2 theta plus tau xy sin 2 theta plus tau xy sin 2 theta. So this will give me my final expression for the computation of transformed normal stresses. Sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sin 2 theta. Is everyone okay with this expression? Is everyone okay with this expression? Okay. Now next expression we have is sigma y dash is equal to sigma x sin square theta plus sigma y cos square theta minus 2 times tau xy sin theta cos theta. So sigma y dash is equal to sigma x sin square theta. We are going to replace it with identity 1 minus cos 2 theta over 2 plus sigma y cos square theta is replacing with the identity 1 plus cos 2 theta over 2 minus tau xy 2 sin theta cos theta is replaced with the identity sin 2 theta. Okay, then we are further simplifying this equation. Sigma y dash is equal to sigma x over 2 minus sigma x over 2 cos 2 theta plus sigma y over 2 plus sigma y over 2 cos 2 theta minus tau xy sin 2 theta. So sigma y dash will now become sigma x over 2 plus sigma y over 2, sigma x plus sigma y over 2 minus sigma x over 2 cos theta plus sigma y over 2 cos theta. So minus here sigma x minus sigma y over 2 cos 2 theta. Over here you can see this is minus, whereas over here it was positive. So minus minus will become positive. So sigma x minus sigma y over 2 cos 2 theta minus tau xy sin 2 theta. So now this will give me my expression for the computation of transformed normal stress sigma y dash, that is very much similar to sigma x dash. The only difference is the sign: positive, positive, negative, negative. ठीक है जी. So sigma y dash is equal to sigma x plus sigma y over 2 minus sigma x minus sigma y over 2 cos 2 theta minus tau xy sin 2 theta. Is this clear? Any question? Clear?
Yes, sir.
Okay.
Yes, sir.
The last expression we had is tau x dash y dash is equal to minus sigma x plus sigma y sin theta cos theta plus tau xy cos square theta minus sin square theta. This is sin theta cos theta. So this will be, this is not 2 sin theta cos theta. This is just sin theta cos theta. So it will be replaced with the identity sin 2 theta over 2. This is cos square theta minus sin square theta. So this identity will be replaced with cos 2 theta. So tau x dash y dash will become equal to minus sigma x plus sigma y sin 2 theta over 2 plus tau xy cos 2 theta. So tau x dash y dash will become minus sigma x over 2. When this bracket will open up, this will become minus sigma y over 2 sin 2 theta plus tau xy cos 2 theta. So this will give me my expressions to calculate the transformed normal and the shear stresses. The point to be noted here that these relationships are function of normal stress state and theta. So if I just know the theta, I can calculate the transform, normal and shear stresses. If this is clear, then we will go back to the book. If you have any query, please let me know now. If it is clear, then I am proceeding to the book. We started with 42 students and we are currently having 36 students. Okay, so these are the final expressions which we have obtained now. Guys, just about the numbering, we will follow the same numbering of the equations as the book, but there is just one change. This is over equation 1, this is over equation 2, and shear stress is over equation number 3. Please make your equation of the shear stress is your equation number 3. Rest we are going to follow exactly the same. You can see there in the book as well, they have followed the identities. Sine 2 theta is equal to 2 sine theta cos theta. Sine square theta is 1 minus cos 2 theta over 2, and cos square theta is equal to 1 plus cos 2 theta over 2. This was all about the derivation. We have done the derivation in detail. Now tomorrow we will solve the numericals related using these formulas. Sigma x dash is equal to sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau x y sin 2 theta. Tau x dash y dash is equal to minus sigma x minus sigma y over 2 sin 2 theta plus tau x y cos 2 theta. And this sigma y dash is equal to sigma x plus sigma y over 2 minus sigma x minus sigma y over 2 cos 2 theta minus tau x y sin 2 theta. ठीक है जी, tomorrow we will do the numericals. If you have any question, please feel free to ask me now.
सर डबल एंगल आइडेंटिटीज में हमने क्यों ऐड किया है?
डबल क्या कह रहे हो, आइडेंटिटीज को क्यों ऐड किए?
सर
उजैर आपकी आवाज ही कट जाती है मुझे. व्हाट आई हैव अंडरस्टूड यू आर आस्किंग कि जी आपने डबल आइडेंटिटीज को क्यों यूज किया. द रीजन फॉर यूजिंग द आइडेंटिटीज इज टू सिंप्लीफाई द इक्वेशन. ठीक है, टू गेट द सिंप्लीफाइड वर्जन ऑफ द इक्वेशन. ठीक है, इट विल नॉट चेंज योर आंसर बट इट इज द सिंप्लीफाइड वर्जन ऑफ द इक्वेशन. Any more questions? Okay, Uzair. So tomorrow, guys, please revise today's lecture, and tomorrow we intend to do the numericals. Okay, so kindly revise the lecture, and tomorrow we will do the numericals. If you have any question, please let me know. I am stopping the recording. Stop the recording. So recording is stopped.